Let's take a look at this concept. The definite integral of a rate of change gives the net change. So this is using the fundamental theorem of calculus in a particular way to deal with these types of problems. So here we have a rate of change, the derivative of the function x of t. X prime of t is equal to t squared. And we also have an initial condition. We know that the antiderivative of x prime, which is the function x of t, evaluated at t is equal to 3 is equal to 5. How can we find the value of the antiderivative function at t is equal to 7? So we can use the fundamental theorem of calculus as follows. We know that when we have the definite integral of x prime of t dt from time is equal to 3 to time is equal to 7, by the fundamental theorem of calculus, this can be evaluated by finding an antiderivative of the integrand, which would be x of t, and then we would evaluate the antiderivative at the upper and lower limits of integration and subtract. So when we set it up like that, we have the definite integral from 3 to 7 of x prime of t, which is of course t squared. That would be equal to the antiderivative evaluated at 7 minus the antiderivative evaluated at 3. And since we're interested in finding x of 7, we can simply solve for x of 7 by adding x of 3 to both sides of this equation. So we will have x of 7 is equal to x of 3 plus the definite integral from 3 to 7 of t squared dt. And x of 3 is given to be 5. Now this is most useful for problems that you may not know how to find the antiderivative for. In this particular problem, it is easy for us to find the antiderivative of t cubed. But if you have a problem where you don't know how to find the antiderivative of the integrand, but you have access to a graphing calculator or Desmos, then you can evaluate the definite integral using your graphing utility and add it to the given initial condition to solve for what you want to find. And this is one concept that you will have to use for a part of the free response problem from your homework for tonight.